Today I'm going to take a look at this gigantic tape library. It holds these 80 gig DLT tapes. This is actually the cleaning cartridge, but it's the same size, just a different color. This thing will hold 8 cartridges, and it will swap between them as needed. It's got one tape drive, but holding spots for 8 more, so it can 8 more cartridges, so it can shuffle them around, and it's quite slow at doing that, but it gives you a combined capacity of all the tapes. This one holds 80 gigs. It's the HP StorageWorks 1.8 Autoloader. It's also called the VS80. They hold 80 gigs, and sometimes they're listed as 160 gigs because most tape drive manufacturers count the compressed capacity as their size, which is kind of misleading because you can't compress stuff like JPEGs and things like that, which are already compressed. So if you're backing up already compressed data like video or audio files, you're not going to get the 160 gigs. So it's kind of a lie. This thing is a 2U sized rack mount unit. It has this nice recessed power switch. There's a ultra high density 68 pin SCSI 3 port at the back, 320 megabit a second, and there's a nice little display. It's a 16:2 with 4 controls and 4 LEDs, and it makes a fair amount of noise. It's got, I believe, just one fan in it. It pulls about 16 to 18 watts idle, and I know it goes up to about 23 when running the actual tape drive, and a little bit more than that when it's shuffling the cartridges around because it's using the large motor. And it makes, believe it or not, that is a normal sound. That is a stepper motor controlling the read and write head, which we'll get into later, but it's actually supposed to do that. So the display is saying it's initializing, and it will go through each tape. And I have the cover unscrewed, so let's just see if we can get this open. Okay, so you can see the actual tapes moving around the carousel. It only moves counterclockwise. I currently have one tape taken out, which is that cleaning tape, so let me see if I can get a better angle on this. So now it's cycling through each tape. Right now it's loading reading the information off this cartridge, and then it will rewind the tape back into the actual cartridge and switch to the next one. And it will go through each one. It'll take quite a while for it to first initialize. The tapes that this thing uses, these DLT Mark IV tapes, they're similar to a more modern one like an LTO drive. I believe they work on the same principle, where instead of, say, a VHS cassette, where you have a spool of tape winding onto the other spool of tape within a cartridge, and it's just going by the read heads like once it wraps it around in a VCR. These are kind of, you can kind of think of it like this. This half is the tape, and this half is the empty spool. And the half with the empty spool is always in the drive. So what's happening is, when this cartridge is loaded, it's pulling the tape out of it and starting to spiral it up on this big spindle with a rather large motor. It reads all the data, and then when it's done, it will wind it all back into the cartridge. The actual cartridges only hold a single spool, and it's just unwound. The read-write head, like I said, can move up and down. Now if I send the command to unload the drive, you can see it winding it tensions it, I think, so it goes back and forth a few times. But it will wind it a few times. It's moving the read-write head, and now it's actually just loading all the tape back into the cartridge. And what's going to happen, there's these little grabber arms right here. There's 2 of them. And once it's all wound back in, which it should be right now, it's now going to actually pull the drive out. See, grabs the sides of the cartridge, or pulls the cartridge out, grabs the sides of the cartridge, and now it's pushing it in, and it just nudges it in. So now it's just gonna bring it to the next slot, and we can issue all sorts of commands, such as importing, exporting. Importing and exporting mean you want to remove it permanently from the library, because whenever you install a cartridge, it reads its it has a catalog. It will read the catalog and then index it so it knows where all the files are. This unit I bought actually came with all these cartridges, and I was curious as to what was on them. I wasn't sure because there are so many different backup drive manufacturers and backup software, and you know, it could be on Linux, it could be on Windows, who knows. I wanted to see what was on it. I have a SCSI controller card and whatnot, and I could not get it to even properly work in Windows. It would detect the drive and the SCSI card and all that stuff, but I was trying to use Retrospect, and Retrospect just refused to see the actual tape library. So I don't know, I had like the full ultimate mega edition of it that has tape library support. So I'm not really sure why it wasn't showing up, and I don't have a Linux machine to try it, nor do I want to like fiddle with it. I'd have to learn how tape drives work under Linux to even give it a shot. This is the menu interface. As you can see, it's showing that there's no cartridge in slot 8, and I can just issue commands such as importing, exporting, loading and unloading cartridges. I can tell it to clean drive with the cleaning cartridge. Reinventory goes through each cartridge and checks its index. And if I go to information, it's got 3,614 cycles. I'm not sure if that's revolutions or load unload cycles. I'm not really sure what the deal is with that, but it also shows 32 events and the firmware revision. I believe this particular model, this HP made unit, is also available as a Dell. I think it's the 120T, but I'm not 100% sure if they're identical. Dell has a couple different models, so it's possible it's not exactly the same. There's also a reset configuration. You can change the SCSI ID. You can update the code, which I'm not really sure what that means. It might mean the serial numbers. It's cycling through all the cartridges right now. Unlike some more advanced autoloaders, this particular unit does not have the ability to... Oh, it wants me to put a cartridge in. That's weird. Okay, so let's see what it does with a cart. To update. Some of the more advanced drives have an actual barcode reader, and they will read the label off the cartridge, and it can completely index multiple units in a storage library, where they actually have like a rack and magazine of like 20 cartridges. Oh, that's weird. It's actually running the cleaning, even though I told it to, what was it, re-index or whatever it said, it's cleaning it. Bizarre. More advanced ones have the ability to do these fancy barcode scanning indexes and stuff, but this one simply has to go one by one and read the cartridge. This is the cleaning cartridge. As you can see, it's actually a white, like, fabric strip on the cleaning cartridge. The teardown I'm going to do today is going to be a destructive one. I do not need this thing. Its capacity is much too small for me to use for anything other than ripping apart. I mean, 80 gigs of cartridge, even with 8 cartridges, is not enough for me to make any real use of. It's just ejecting the cartridge now. So I'm going to rip it apart, see what kind of interesting stepper motors and stuff we can find in it, and we'll go from there. And yeah, I'll open up the cartridges too so we can check it out. The actual tape drive is made by a company called Benchmark. Benchmark, I believe, was purchased by Quantum. And it's the actual drive is a DLT VS640 Slim, and it's made in the Philippines. The drive itself has a cover on it, a little sliding door, and it's actually quite neat to watch it open up. So I'm going to tell the unit to import into slot 8, which is empty right now. and it just happens to be right here. So I'm going to start the import, and it just slides the unit open, push it in, it grabs the cartridge, pulls it out of the way, and then closes up. Now it just says locking carrier. It always locks the carrier when it loads a cartridge. It moves it to the next one. So I guess it's just making sure that the actual cartridge is aligned properly. I've removed the top plate of the drive mechanism so we can see how the actual tape path works a little bit more clearly. The tape loads in here, and there's a motor under here for actually controlling the spindle. There's also a small bit of tape inside the unit already. The drive contains a few inches of tape, and there's this little hook part. Now what happens is the end of the tape has a small hole in it, and it loops onto this, and basically it splices, like temporarily splices the two pieces of tape together. That allows this already installed piece of tape to guide it through the loading mechanism. And you can see it goes through two pulleys. There's a it looks like a photodiode because there's holes in the pre-installed tape. So I think what it's doing is it's counting the holes and making sure that it's loaded correctly back into the tape. So it passes through there, and then it goes to the head, and the head is actually movable. It moves up and down. Another little spindle, one more, and then the actual motor unit, which is like it clicks back into place, and I can't move it manually, so it's either a stepper motor of some kind. You can see the coils all the way around it, or it's got like some brake on it that I can't see. So I'm going to tell the drive to load a cartridge. Load cartridge. I think we're at slot 2. Yep. So it's all opened up the plastic connector. The drive has been pushed in, and now it's going to, you can watch the dots move away. There, you see how the little transition of the two like looped sections? That's it switching over to this tape from the pre-attached tape. And as you can see, it spins at quite a big speed. I wouldn't want to stick my hand in there. I think that would actually hurt quite a bit, because it's a couple millimeters worth of metal on the top and the bottom half, and it does spin at quite the speed. So it's just reading the, it calibrates first, then it reads the actual directory. One thing I've noticed is that once it's finished loading, the mechanism appears to be unlocked and you can wind it. So I'm going to try and wind it more than what oh, it's flashing now. Error. Code BF. Oh, and it's moving the read-write head. Okay. Is it going to clear itself from there? It's winding the cartridge back, or the tape back into the cartridge. Oh, it's pulling it. It's winding more onto the tape now. Oh, drive rewinding now. You can hear when the motor starts up. I don't know if you just heard that. It may not pick up on camera too well, but you can actually hear like the PWM motor drive playing like musical notes, like as it revs up in speed. It's kind of neat. I think it's going slower than usual just to be sure, because it's not. It knows that the tape's been misaligned because I manually wound it. So I think what it's doing is it's going a little slower than usual because it's not quite sure when the tape ends, so it doesn't want to like rip it or something. Alright, so now we just transitioned over into the end of the cartridge, and this is now the actual pre-assembled tape. Oh, it's winding it back in now. Oh, I guess it's not actually going to eject it. Maybe it just unwound it and now it's winding it back in. It went back to the point where the holes in the tape give it a point of reference, and now it's doing its normal calibration and whatnot. When loading from the actual carousel, the cartridge actually gets pulled by these little grabber arms, which are kind of hard to see. There's one right here. And when I tell it to load, they pull out, they grab the cartridge by the side, squeeze it in, and then you can see them move and push it in for the rest of the way. And then they give it a little shove and wait here. They're sitting right here. They have a little bit of rubber on one side to grip the cartridge, and they also just like ram into it. This mechanism just seems to be just a piece of plastic just to guide it through, and there's a small piece of metal here which I originally thought was just to like clip the cartridge in, but I can actually see that there's an optical sensor being broken when you push the cartridge past it or when the grabber arms move it. This is the actual cleaning cartridge. As you can see, it winds quite a bit of cleaning tape onto the spindle, which is good because it's using a large portion of the cartridge, so you're not just cleaning with the same part all the time. You can see it actually moves the head up and down repeatedly, and now it's rewinding, but it'll actually just run the head up and down over the cartridge, over the cleaning tape, while spinning the cartridge back and forth. There we go. It's transitioned into the actual attached tape. Time to take a better look at these cartridges. This is the cleaning cartridge, but it looks identical aside from color to the regular data cartridges, but I'll open up one of these too. So there's a label on the front. It's just a regular paper label. It's dated 2008, so I guess someone was using it. I don't know what company these are from. There's a giant read-write lock switch. You can see this is how it's actually read by the drive. It's got a little plastic tab. Around back, this mechanism, let me get my little spreader thing. This clicks in, and I think this is what removes the lock on the tape spool. And there's also a small one here that lifts up and that opens up the cartridge. And nothing on this side except just space for it to grab it and whatnot. So let's get this guy open. Oh, wait a minute. I think this uses different size screws to the other cartridge. Yeah, this one uses Phillips number 1, whereas the data cartridge I initially grabbed the screwdriver for uses Phillips number 2. It's kind of weird. They're plastic, self-tapping, of course. Nothing fancy for cartridges. And one more, four screws. Oh, I felt a spring release. Okay, so there's a spring holding the spindle down. And there's one of the little, I think that's just guiding the tape. It's the actual door assembly. And take this off. Yep, there's another spring here. Yeah, nothing too fancy on that. Put that in the big pile. Garbage, which this is going to produce a lot of. There's miscellaneous parts, the label. Huh. It's actually cut out from something, the packaging, I guess. And yeah, just the somewhat tough plastic. This is actually not too bad. And here's the actual spool of cleaning tape. You can see there is actually the sensor holes, and there is a, this is the pull tab, and my cat is making very strange sounds, which he often does. So it pulls in, this part gets latched on to the portion that's already in the tape drive, and it pulls it through and reads the holes. And presumably there is cartridge information on this, like how many cleaning cycles it's gone through. And we'll just take a better look at this. There seems to be another spring in there. Oh no, it's a bearing. Yeah, it's a bearing. Wow, it's actually a very smooth bearing. And there's teeth along the edge. There, get those in focus. Teeth along the edge of this, which don't seem to... Oh, okay. I think I figured it out. That little push tab that we saw earlier on the outside of the case that releases the spindle, what it's doing is it's moving this piece, and see, this actually has teeth on it. So this is sitting here locked into this, preventing the tape from unwinding, and then when it gets pushed into the unit, this gets lifted away from it and allows it to turn. So let's just take a look at this. This is a well, there's just a splice here, but it feels almost nylon, this tape. And I think further along I did actually see some discoloration of the tape. Maybe it's just the lighting. But yeah, there is quite a bit of tape. Oh, there we go. Quite a bit of tape on this thing. There we go. That should clean a few drives right there. Yeah, it looks practically brand new. Oh well. As expected, the data cartridge is exactly the same. There's a better look at how the locking mechanism works in this one though, because it's still attached. You can see how there's a set of teeth on this piece of plastic, and this is it unlocked, I think, and then it releases and then puts force against the tooth edge of this thing, the main spindle. There you go. So yeah, the actual cartridge has this rigid plastic backed starting lead on it with the little grabber piece, and then it quickly transitions to a very, very thin magnetic tape. See, very, very thin. Yeah, I think the newer LTO drives are even thinner. I know the track size is a lot smaller. And then it just, when it's in the drive, it just yanks on this, and this spins very smoothly. Very smoothly, this little bearing piece. Yep. Fun! So I think I'm going to start by trying to cut the, there's a pulley system that's running the units around. See, they all kind of pop out, but they're probably clipped in at the bottom. Oh yeah, okay, here we go. This little pin goes through the track, the rubber track. I guess that's, yeah, it's like some kind of rubber, maybe with fiber reinforcement. And this holds the cartridge. It is actually locked. Ah, okay. So there's actually a small plastic mechanism on each one which locks the cartridge in, and then once you've rotated past, can't move this thing. Once you've rotated past this point, the the plastic's no longer being held and it locks the cartridge into place. That's probably why it shifts it forward when you first insert a cartridge. So I'm going to try and pull the rest of these modules off. Oh good, the track's coming off. Just pull the whole assembly out and there we go. Cool. Here's the track. There's 2 grooves. It's actually very clean. Expected it to be dirty. This side has the motor. You can see the extra gear hooked up to it, whereas these are just just wheels to keep everything on track. They're also sprung. They've got these green pegs in them. Oh, that one doesn't want to come off. Okay, so this one's actually capable of moving. It looks like these are fixed. That's fixed too. So it's just this one. This one can adjust slightly to probably compensate for tension in the line. There. Also, there was no spring in it. It was simply just pulling in when I removed it. So I'm going to try and get this big piece off, and maybe the front. I think that just disconnected everything from the top or the bottom plate, but the actual parts are all still stuck in here. So there are a couple of screws on the top of this. So let me see if I can just. Oh, of course, there are those damn Torx bits. Not that I have a problem with Torx bits. It's just I like my Phillips screwdrivers, and it's a pain not to get to use them. So I removed all the screws from the bottom, but that didn't seem to do anything. There were 2 screws up at the top here, and it seems to just be plastic. Oh no, wait, there is a screw, but I have a solution to that. There we go. Like I said, this is garbage. I do not need it. There's a little flat flex cable running to the display and the buttons. Okay, so it's actually a pre-built module with a little chip on board. There's the bottom screw I didn't bother to take out. There's only 3 screws on this. The last one's just a clip-on retainer, like for a heatsink. I'll just snap that off too. Here's the recess for the power switch, which is up here. Just snap this thing off. Custom built board with the display and a little chip on board. That's probably just a standard Hitachi driver and just some passives. Nothing special, just longer than usual tact switches, but that's it. So this is the mechanism for the door. There's a bit of dust on it, but I can see I don't know if it's a standard motor or a stepper motor, but there's the actual action. And not sure how they're sensing that. Maybe a stepper motor, and that they're just calculating the distance, and if it's not working, they know something's blocking it. Because I don't see an actual mechanism. There's this spring, which I think is for the rail. This little piece that runs in here. There. So when the unit's coming along, it will trigger it, but even that I don't see a sensor of any type on. So this is going to, okay, so this just comes off. This is just the portion of the door that you see, and then there's all the covered up stuff. Oh, there is a plastic piece here, so maybe there's an optical sensor in here. Yeah, okay, so there's a it looks like there's one right here. Sensor right in here, so the piece is blocking it when the door's closed. Okay, so let's see if this. All right, give me a second. I'm gonna unscrew all the stuff at the back from the back panel. I think that'll release everything. Okay, I've unscrewed most of the stuff on the back. Let's see if we can. Oh, I think there's some grease on the side of that. Okay, so there's a grounding lug. Nice and bolted on. Let me get some cutters. There we go. And the SCSI cable's also back here. It's attached. I don't know if I can. I think it's just a slot. Oh, okay. It's not a hex driver, it's actually a slot for a change. There's actually an expansion panel here. And I noticed it earlier, and I also noticed that there's nothing on the inside where it is, except for this small opening. A little place for it, like 3 centimeters wide that a cable or something can run through. I'm not sure what would. It must plug into one of the boards down in the bottom, and that's simply a back plate for a connector. Maybe there's a fiber channel upgrade. Oftentimes when things don't have upgrades, like if you look on HP's site, I didn't see any upgrades available. But oftentimes when you're looking at a product like this, where I'm fairly certain it's also made by Dell, you can look up the Dell version and you'll find that they have the plate in the exact same spot, and that one has the upgrade listed. So you can actually figure out what it is they support. Okay, so that's the back plate, and you can see the cover on it for the expansion, and then there's just fan opening and stuff like that. Put that in the recycling bag. Okay. I managed to get the bottom plate off. So this is the front of the unit, and the back towards there. You can see the fan, the switch mode power supply, the main logic board, which is also attached to the drive, I think. The large motor that drives the actual conveyor belt, and it's a stepper motor because it doesn't seem to be going anywhere. The small motor here, it looks like a little regular like DC motor that opens and closes the door. This is that spring unit for the pulley, and this is the flat flex cable that runs to the display. There's also the SCSI connector, which is kind of cool because it's. Let's see if this just comes off. Come on. It's actually clear, so you can see my hand through it. That's kind of cool. I like that. Not very practical because it's very rigid, but. So, and they are also using Molex power connectors and what appears to be a floppy drive style connector over here, which runs to the big stepper motor. It's a little wobbly, but this is the power supply with a plastic shield and a fan, which is a 3-wire. They aren't controlling the speed on this thing. It's always just spinning at the same speed. But it does have tachometer, presumably to warn it if the fan has died. This big multi-way connector runs to. It's a combination of the sensor at the front for the door and the DC motor. And we got power coming in, running to this standard Molex connector, but there's also a second connector here that runs, it's probably 12 volt, that runs to the motor directly, I think? It's hard to tell. It's kind of a jumble of wiring here. I don't know how this connector works. I'll just rip it apart. Maybe that'll tell me. Oh, okay. It's kind of an interesting little connector. This is the grabber arm assembly. I'm just going to get this ribbon cable out the old-fashioned way by destroying it. And here we go. It runs along this little rail. and presumably one of these controls, well, yeah, I would say one of these controls the movement of the motor along the rail, and the other one controls the width. I can get a better understanding of how these things work. And there's also a single-sided board, just one of these cheap guys right here. The neighbor is watering plastic, it sounds. That's probably very important that they do that, especially at 8:30 at night. So yeah, there's just a couple resistors, and maybe those are inductors. Nah. Well, you got a little sensor here, which is, when this is installed, it's here. Oh, okay, so it's this little sensor here. When the arm comes in, this one has a little plastic tab. So this is what tells the unit that the arms have come in. So it blocks the sensor when in, but when it's out, it won't block it. So let me see if, oh, these are very small Torx bits, but I'll try taking off these larger ones first. If I can find my screwdriver. Oh, it's down here. Normally I'd keep track of all the screws I'm taking out. One, they're almost all identical self-tappers. And two, I'm not planning on putting it together, so I just kind of gather them all up at the end and throw them into a big bag to recycle, since I'm pretty sure you can recycle just plain screws. This looks like it just comes right out once I take these out. With the assembly out, you can get a clear understanding of how this thing works. So this is the top, this is where the cartridge would slide over, and here is the pair of grabber arms. I keep calling them grabber, but they're used to push as well. If I pull them out too much, they come off these little guides, so obviously they're not supposed to come out that far. There's the little sensor for the, let's see if I can find a cartridge. The actual caddies that hold them have this piece of metal right here, and I think the way this works is these line up and this pushes down and blocks the sensor when you've got a cartridge in the unit. And you can hear the motor. There's a teeny look at the effort they put into this. There's actually a teeny tiny board in here for just that one little connector. They couldn't have figured out a way to incorporate that into one of the other boards. Huh, weird. But so one of the motors is running the grabber arms and one is running the conveyor. You can see the gearing in there. For this thing, there's a tooth line along it, and it just slots in. Just a molded piece of plastic at the back. Rather intricate gearing system for these arms. See the, okay, so this motor on this side is what's controlling this one. These are obviously going to be misaligned now, but hang on, let me see if I can just slide that in there. Oh, I think I need to take out this motor. It's just gonna, or this pulley. There we go. So that's the extender mechanism. Without the stepper motor, it moves quite smoothly when it's not, getting jammed because I'm holding it. Take off all these gears. A couple little ones. That's the motor. Now there's the sensor here has a small connector, small wire right here, just running to the other board. You know, it's weird that they couldn't just incorporate all, like put the control PCB, like this connects all the motors to a higher density connector that goes to the board, the flat flex. Why couldn't they just put this in a spot that would let them mount this on it instead of having to make separate connections to it? It just seems kind of weird. Okay, so I can pop these off. They're little stepper motors. They are Portis cap? Never heard of them. I'm sure they're popular. But there's two of them. Doesn't have any useful information. I'd have to look up the model numbers of them. And that's just the sensor and nothing else. Boring. The motor for the sliding door has this little unit on top of it. Let's see if I can get this out. It's the same size screw as the rest of the case. Okay, so it's just holding a gear from the little motor. Okay, so that's what's actually turning the. Let's see if it's when it's inserted, it sticks out right here, and that's what's actually turning that slider. So let's see if we can get this. Switch screwdriver bits. Get this little motor out. All these pulleys just slide right off the motor shafts. So sorry, this is kind of wobbly. The motor here is held in by Phillips screws, which is so annoying considering the whole case uses Torx bits. But the motor should come right out. All the other motors had gears on them, but they weren't really glued on. They just slid off the. See, I think they're. Yeah, see, they've cut out two holes so you can pop it out. But the other ones actually didn't need to do that. They came out anyway. This one only has two connections. I'm assuming it's just a regular DC motor. Let's see if I can get this wiring loop out of here. Yeah, so this runs all the way to the like a high density, not high density, but a fairly high density connector. Now these are giant Torx bits on this big stepper motor, so I'll have to get to that in a second. There's not much here except this teeny tiny little contact sensor, or optical sensor. They're infrared. See, one transmits, one receives, and it sends a signal across, and if it's been blocked, it knows. Yeah, it's just got a little 3-pin connector. They're all 3-pin. The large stepper motor is here with its gigantic Torx bits, or Torx screws. They're actually Torx. Oh, they're just T15s. I guess it's just because it's flared out a bit. It just kind of looks like a larger Torx bit than T15, which is pretty standard. Okay. Okay, so there's actually, this stepper motor is intertwined with the power switch at the front. Get a little bit of slack on this thing. It's an NMB made in Thailand. Yeah, I can feel little steps. It's a pretty nice unit. 4-wire. With it removed, you're not fighting the stepper motor, so you can actually spin the wheel, this is the whole drive system for that huge conveyor belt. Just the stepper motor connects in here, turns this, which turns this, which turns the actual pulley, or turns the final one, which turns the actual belt. I took 4 screws out and it removed the actual drive assembly from the rest of the chassis. One thing I forgot to mention is that loud kind of buzzing sound. It's like a when the unit's turned on. This piece of plastic right here can actually vibrate. I think it's for tensioning, because like when it happens, you can see like it's moving all the tape that's pre-attached. So I think it's something to do with tensioning it. It just shakes it to just level everything out, maybe, or just even out the tension on it. I'm not quite sure, but we'll never find out now. So this is the assembly, and it's in this like, it looks like a Jawa sand walker or something. This big chunk of plastic. So I'm gonna see if I can. They're Phillips screws again, swapping back and forth. Glad my WIA screwdrivers fit in here. These are electrically insulated for like something absurd, like 2,000 volts or something. Oh no, 1,000 volts. So they have this plastic all over the screwdriver, which means it's a little hard to fit into some tight places like computer monitors. The screws are usually pretty far recessed, and I have to grab a inferior one. Now this may plop down and make a loud bang. Oh, I guess it's being held in by something. Oh, it's just tall enough to be on the ground. So here's the plastic. It's got a big piece of foam. Yeah, just a big piece of foam. Big carrier. This thing's massive. Into the pile. Bottom of the board. There's a small ribbon cable running inside. Here's the high density SCSI connector. And these are all the connections to the outside world, the motors and whatnot. So I think we'll start by taking off these Phillips. I think they're Phillips number 1 though. Yep. So there's one tiny ribbon connector coming out here, probably to some sensors. I don't know what kind of, yeah, okay. Disconnects. Okay, I see a bunch more flex connectors. There's one here, 2 more. I don't care if any of these break. And an actual, this is probably to the big stepper motor. Actual connector. Alright, so this is the giant Mitsumi motor, which this one turns the drive. And this one turns the big flywheel assembly. That's kind of cool. There, you can see how it's all interconnected. I kind of want to see what happens when it goes too far. It should just let go and like fling out. Yeah, I think this is supposed to pull in by itself to release it. When this is parked, it's on this little hook. So I think what happens is the mechanism probably moves this piece out here and pushes this out of the way, releasing this, which is supposedly hooked on to the other cartridge by now. And then this, I think I can release this. I think this thing does actually, maybe not. There we go. This thing seems to lock when it's idle, so I'm not really sure how it's doing that. But so when it pulls through, it's coming through, so there's no tension on this. There. Comes through here. This is the optical sensor that reads the marks in the thing. Oh, okay. There's a piece of plastic right here on this. So it only spins freely when this is actually out of the way. So there you go, there's the pre-attached portion of it. Let's get this out. It's optically encoded to let it know exactly where it is on the line. Just wind that. Oh, it disconnects. Okay, so there you go. This is probably a replaceable part. So this is held in with 3 Phillips. Teeny tiny Phillips. Let's see if this will work. Oh, it does. Perfect. So this is the actual take-up reel. Huh. It's plastic. I thought it was metal just from its appearance. It looked like it was like a die cast, but it's not. It's just actually pretty brittle plastic. Here's the motor, the little plastic or paper separator. Nice. It's a very nice motor. Let's see if I can take it out. Hopefully this doesn't disassemble it. Would like to keep this. Maybe I can use it for something. Highly unlikely, but be kind of cool. Come on. Fighting with this thing just to get the screw out. Okay, so there's a third one. That is the stepper motor that it uses. I mean, actually it's not a stepper motor, it's like a multi-phase motor. Yeah, it's just a multi-phase, I think. Uses a probably like a 10-pin connector, and it will just fire each one in sequence, which is how it provides such a smooth drive when it's running. You can hear that it's very, very smooth. There are Hall effect sensors all over it though. 2, 3 of them. Yep, very nice. Unfortunately, it doesn't like look very impressive when it turns. It's just everything's stationary. These are all stationary. There's presumably a magnet right here. Yeah, there's a fairly weak magnet. This is where the cartridge actually goes, and the motor assembly for assisting. Because one thing I noticed is that when the cartridges are free and you're just unraveling them, it will overspin. Like, because of the bearing on the actual cartridge tape, it spins so much that it will wind on itself and go the wrong way and just get all tangled. So I think this is basically used as tensioning to keep it from unraveling. There's a button here, and this is for when this is installed in a case, because they're probably using, yeah, there's LEDs too. They're using a drive that would be separate on its own with a different board probably. This board looks a little large for a case, but the connector and the button, or sorry, the button and the LEDs are still on it because it will function on its own. And that would normally be the front panel and not have a giant autoloader on it. Oh, stupid screw. Okay. That's one thing I hate about Phillips screws, is they strip like crazy. In the rest of the drive we have a bunch of really, really nice bearings. Like these are so smooth, these little rollers. Let me see if I don't know if I can actually unscrew these. Turned. I don't know if it's just turning with it. I have pretty crappy pliers. This may not. I'm starting to think this may not be a screw. Oh. Yep. Okay, so they've got a spring on them. That's why they can bounce up and down a little bit. And yeah, there's a bearing on one side and the other. They've got two bearings, and here's a little spring. Okay, so moving along, we've got the actual reed head. Let me see if I can get this off. Now this motor over here actually controls this little guide. I think what this is doing is it controls the distance the tape is from the reed head, which is a little odd. I'm not really sure why they need to do that. Why would they need to adjust the distance of it? Maybe it compensates for vibration in the tape or something? Okay, so there's a bearing on the top, and this is all like kind of like shock dampened. Let me see. I'll just unscrew this too if I can. Who cares? Take it all apart. Huh. screws are a lot longer than I thought they were. So since this motor, I think it actually also turns the screw drive on this. So I think the motor is doing both jobs. I'm not sure what actually makes it vibrate, because when this was running, when it first starts up, there's a big vibration of this piece of plastic. So I'm trying to see if this will come out. Let me get a slot screwdriver. Let's see if we can get this out. Oh, too big. Where did I put? Oh, here we go. Losing my screwdrivers. Okay, so this is just lowering it. Let's see if I can just keep doing it and see if it unscrews. Nope. So I can actually raise and lower this. Let's see if I can get this out. Get rid of those. Okay, so there's a bearing that's going right into the base of it, but it seems to just slide out of it. But I see a couple more screws. I think. Get rid of these other plastic guides. I took a little bit more of the assembly apart, and you can see the, oh, hi cat. You can see the little optical sensor they use to detect if the tape is present, and presumably the openings in the tape, the holes that they've put in. Can you stop rubbing up against the camera, please? 18 pounds of fur. Anyway, going to try to get the rest of these little guides off the rollers. They're very stuck on at first. I did notice that one of them is different than the others, which we'll see in a second. It actually has an optical encoder on it. Okay, there's one. Oh no, you don't. Hey, stop it. Okay, starting to. Oh, can't take it out yet. I think I have to remove the optical sensor. Just get this screw. Okay, there's one more screw in there, which I don't think I'm supposed to take out until I take out the rest of this. Let me see if I can get this motor out. This is just a stepper motor. It's quite small. Does not want to go anywhere. Take off some of these side. There's multiple brackets along this side, so let me just see if I can get some of this stuff off, and maybe that'll let us get into this a bit easier. Cat is meowing at the helicopter. Two more screws at the back. Oh, of course they're tiny. Let me just see if I can take this whole thing off. Ugh, So many different size screws. So many, you know, they're half Torx, half Phillips. Quite annoying. So it sucked to reassemble. Oh, perhaps he's looking at my gecko. We have a lizard. It's very rare that the cats notice that we have one. He's looking right at her, making weird meowing sounds. Okay, let's see if this... Oh, one more back. Alright. So this is just the part of the frame that holds the whole drive unit in. It's got a barcode on it. Yeah. Firmware version and stuff. Nothing too interesting. Okay, so now the motors come out. This is a little stepper motor. I can feel the little steps. No real information on it. It's another Portis cap one. 12 volt. Okay, so see if we can take this whole assembly apart. Okay, let's go spring on top. I may have to apply a bit more force. There we go. Okay, so this is the actual little guide. You can see where the tape goes through, and it can move it in and out, closer and further away from the read head. And there's a big gear on the bottom of this, which raises and lowers it. It's kind of cool. Nice little worm gear. And dual flat flex cables, presumably one for read or one for write, maybe, or maybe they're a mixture of the two, and it simply has two halves. So it doesn't seem to actually unscrew it. Not sure how they're keeping this together. You have to just try and pop off the plastic. Something's breaking apart. Let's progress. Oh, okay. I think it may just completely unscrew. No, it's just resetting. Okay. Oh, there's a little plastic. Oh, okay. That's kind of clever. So there's these little plastic guides for the ribbon cables, and they have this other piece that clips in. If I can get it to clip back in, it like clips back in and holds it flat. But if you unclip it, these fold, and then you can push it through and take this metal piece off. That's kind of clever. Seems a little overcomplicated, but it's clever. I think we can just pop this off now. Alright. You can actually see the gears. Still can't get this read head off. Oh, okay. There we go. It's just the gearing mechanism. You can see the plastic piece, the plastic cog moving further towards and far away. Yeah. It's the read-write head. You can almost make out that it's a whole bunch of little tracks. It's got two large plates on each side. Maybe these are the erase heads or something, I'm not sure. Very cool. Seems like it's one big piece. I don't think I can break it down any further. Oop, that flew somewhere. No. This is that wheel that has the optical sensor on it. Now you can see that there's actually a pattern etched into the metal along the side, and then there's this optical reader which goes between it, and it counts the pulses so it can figure out how quickly everything's rotating. They're actually cut into the metal. It's quite flexible, as you can see. You can easily bend it. The last thing on the tape drive is the actual mechanism which accepts the tape. Now when this is pushed in, I think what happens is this motor with a little worm gear on it starts, and when this is all hooked up, it begins moving this piece. It's actually moving it very slowly, I think. It moves this piece of plastic all the way across, which then hits this plastic piece, which unlocks the tape. So I think that's one of the first stages of it loading up. And you can see there's more mechanism in here for accepting it. There's even a little PCB with, I think, a couple Hal-Effect sensors. Something, I don't know, I can't see them there. Last but not least is the tape drive's main board. It's really the only circuit board in the entire device. It has a SCSI connector and a couple power inputs. Nothing too much on the back. It's mostly motor driver related, and the back is like all bypass caps and a few relatively huge resistors. On the other side, we've got a couple custom chips. There's an LSI logic chip that I couldn't find any information on. There's also a Q-Logic chip that I couldn't find any information on. Both LSI and Q-Logic make SCSI controllers and stuff like that, so it's possible these are the main ASICs for controlling the tape drive. We've also got some unique chip, well, not really unique, but kind of an odd mix of chips in that there's a Motorola 68020 here, which is a blast from the past for any Mac user. There's a whole bunch of different forms of flash. Like if you've got these rather large flash chips, and then like a smaller kind of narrow flash chip. This looks like a normal NAND flash chip. And we've got some, there's a Xilinx CPLD, got an Altera Flex, a cheap FPGA. Mostly power stuff on this side. Like these are actually, despite their packages, they're actually 3-phase stepper motor controllers, or power MOSFETs, which is a little interesting. These are all stepper motor controllers. There's 7 of them. Yeah, these are different. More flash, which is for this Zlog Epic, which is an enhanced intelligent peripheral controller. It's basically a Z80 chip with some I/O. You know, nothing too fancy, but interesting arrangement of stuff on it. You've got like a Motorola processor, you got an Altera Flex FPGA, Xilinx CPLD, you got all this custom logic, hyphen 9710, which from what I can tell is a compression chip. So I think that's what's doing the hardware compression for the streaming to the tape drive. Yeah, nothing too interesting on it aside from the weird mix of stuff. This is the power supply for the unit. It's Samsung branded. Do you mind, Moose? The power supply is actually quite simple, and in some ways they did made some really good design choices, and other ways it's just not as reliable as it should be. For one, they've got like a nice big Samsung cap here, the big filter cap. Everything's nicely gooped down with the silicone stuff, so that's nice. And it actually has 2 fuses. It has a fuse on the primary side and the secondary side. But like instead of putting in a holder, they put it in the heat shrink and mount it on the circuit board, which makes it hard to replace these things. Although I believe the heat shrink might be to make it a bit safer, so that it contains it if it blows itself up. There's a grounding lug here, or a grounding wire here that runs off to the chassis, and on the PCB you can see spark gaps. So it is quite a safe board. Like, it is well designed. They've got nice plastic protection between each side. Almost well, I think actually everything. Oh no, I see a couple odd bits, but almost everything is actually glued down with the silicone, which is a nice touch. It's got a decent sized heatsink here, holding the big, I think that's the bridge rectifier, and then you've got the power devices all along here on a nice chunk of metal for a heatsink. But not all the caps are 85 degree rate or 105 degree rated. A lot of them are 85. Although they have a nice big Samsung filter cap. Here's the model information. It's kind of hard to read with the glare on it. Many of the caps on it are actually Capson brand, which is terrible. They're terrible caps. And there's a bunch of little guys. They're all Capson too. And there you can see the second fuse tucked way in there. Here, I'll just rip these off to get to the back here, since I'm certainly not using a totally custom power supply anywhere. These are ST branded. Yeah, there's just 4 TO220 devices in there, but you know, they're done right. They've got the nylon washer through them, and they've got a little sill pad and everything, but yeah, not the greatest caps in the world. And and this is funny, they have the big bridge rectifier here, and they put a cap right against it. Like, why? That thing probably gets fairly warm. I mean, not only do they have the big filter cap near the heatsink, like almost touching it. It's like a millimeter gap. But they have this little one down here that's practically touching it. I think it actually is touching it. It might be close. But yeah, they've got MOVs and stuff, so it's decently built. Like, from a design standpoint, like, there's lots of safety in it. But they cheaped out, and I think probably due to size constraints, they kind of made a couple odd decisions with regards to like capacitor placement, mostly because in almost every power supply, that's what's gonna die. There's one pot down there and a one IC. I'm not gonna bother digging into that, and they've got like a common mode choke set up and everything. Yeah, I mean, like, nah. It'll probably last, because this thing I don't think is a very high current drain device, but it's actually a metal shield here. This piece is metal, and there was plastic. That's actually soldered in, I think. It looks like it's wearing isolation. Yeah, okay, so it's actually soldered in to that pin, I think. That's weird. Maybe it's for radio frequency interference or something. It's a little strange to see what would normally be a plastic shield to prevent any crossover from the primary to the secondary side. It's actually just a chunk of metal, but there was the plastic over it, so it's not too bad. This is the fuse. And what else do we have here? This is the only fan in the unit. It's a Panaflow. It's a 12 volt, 0.2 amp DC brushless. It's fairly loud and not very good. I think Panaflow does actually make quality products, but this one is probably designed for, we don't care about the sound, we just want it to blow a ton of air. And it wasn't even that strong, so I'm not really sure what advantage this has over any other fan. So yeah, not impressed with this one. It was quite loud. Well, that's about it. I've taken the whole thing apart. This is the big stepper motor that moves all the cartridges around. I'm hoping to get one of the better or more interesting tape libraries with a barcode scanner and stuff at some point. Unfortunately, they tend to go for quite a bit of money. This thing was pretty useless due to its low capacity. I mean, with a total capacity of 640 gigs, not very useful considering my NAS has 20 terabytes in it. So, hopefully I can get a better one and we can get a more interesting device to tear down with a barcode scanner and stuff. Hey! Hey! No! No eating. You can swipe, but not... Hey! Alright, just put this back on the wheel. Uh-oh, this could be a little more, this may take a while. Alright, there we go. Perfect, rewind. Back into the drive. Doesn't seem to. I don't think it fits anymore.